Welcome to the session. Today we are going to talk something about servlets and JSPs. This session is primarily focused on servlets, and we will also have some brief introduction on JSPs as well. Right. The prerequisites would be you should have some basic knowledge on the OOPS concepts and Java programming in general. Right. Okay. So this is the agenda for today's session. We'll start off with some introduction on servlets and the web world in general. Then moving forward, we'll have a look into the servlet architecture, the servlet lifecycle. We'll see what the different lifecycle methods of a servlet are. Then we'll see something about the request and response. Then I'm going to talk something about the servlet engine or the web container, right? And we will see how session management takes place in a servlet world. Okay. And later on, we will have an introduction on JSPs and see what the different JSP elements are and where actually JSP comes into the picture when we talk about servlets. Right. And at the end of the session, I'm going to give you a demo where I will show you how to basically code, develop and execute a servlet, right? So at the end of the session, you should know what a servlet is. You should know where servlets are used, how to use a servlet, what are the advantages of using the servlet, right? And you should also be able to develop and execute your own servlet apps. Alright, so let's start off. Request response model. Let us discuss how basically communication takes place in a web world now. So there is a client and there is a server, right? So let us discuss about these two things. What is a client and what is a server? A client is basically something or someone who is requesting for some resource, right? And a server is basically a machine which serves the request, which is requested by the client. Okay. So let us take a simple example. You log on to your computer and you want to check your email, right? So you go to the website. You go to yahoomail.com. So here you are nothing but a client to the Yahoo server, right? So Yahoo server is a web server or a HTTP server, and in this session I will basically use the terms web server and HTTP server interchangeably. Okay, and a HTTP server or a web server is a machine which can take in request from a client and can give back a response, and that response is a static HTML page or any page or any file which is static in nature. It's not dynamic. Alright. So when you log on to yahoomail.com, you send in a request to the Yahoo server, and you're sending in this request across the web, over the web. Alright. And this request is nothing but an HTTP request. HTTP is a protocol. It stands for Hypertext Transfer Protocol, and everything you communicate over the web should be HTTP, right? So this web server can only understand HTTP and nothing else, right? So you send an HTTP request to this web server and it checks for a page you requested in the repository it has. So from its repository it picks up one static page from the bunch of pages it has and sends that page across to the client over the web again, and this is again a HTTP response. So your HTML page is embedded within HTTP and it is sent back to the client. So client here is nothing but your web browser. So the Internet Explorer or Mozilla Firefox or whatever web browser you're using. So that is technically a client to the web server, right? And you are of course the end client who's actually using that. So one thing I wanted to define here is the term web server. A web server is a server or a machine which can take in a request, which can take in a HTTP request over the web and can serve the client with a response. And this response is nothing but a static page, a static HTML or a static file, a jar file, or it can be anything. It's a static file. Alright. Okay. So now that we have discussed what a request and response is, let's look into more details of the HTTP request and HTTP response. Let's see what the key elements are for a request and response. Okay, first the request. So the key elements for a request are the HTTP method. We will basically discuss about this HTTP methods and the differences between the various methods we have in the later part of the session. But for now, you just keep in mind that HTTP method is one of the parameters sent from the client to the server when making a request for a resource. Right? And this method basically would be a get or a post in like most of the times. You either use a get method or a post method. So just keep in mind about this, and we will discuss in more detail about this in the later part of the session. Okay. Second thing is the page to access or the URL. So when you type in yahoomail.com, that text yahoomail.com, www.yahoomail.com is nothing but the URL, and you are sending this URL as well to the server. Okay. And the third thing is the form parameters. Okay. So now, say for example, you typed in yahoomail.com, the request went to the server, and then server sends back the response to you. And that response is nothing but the login page for Yahoo Mail. So that's a very static page, right? Whenever you type in yahoomail.com from any computer in the world, you get the same page back to you. And that's a Yahoo logon screen, right? So that's a static page, static HTML page. So now in this second page, what do you see? In this page, what do you see basically? You see a username and you see a password, and these are text boxes, right? So you would basically type in your username, say for example, you typed in ABC as username and XYZ as your password, and you clicked on go. So the form parameters is nothing but the username and password which you have typed in, right? So the request, the HTTP request contains the username and password in the form parameters, right? So that is basically form parameters. Whatever you send across to the server along with your request is nothing but the form parameters, right? Now, what are the key elements of a response? Number one, the status code. So this status code will actually tell the client whether the request was successful or not. So the client is nothing but, as we have discussed, the client is nothing but the web browser. So when the server sends a response to the client, or in other words the web browser, it sends a status code, and that status code will tell the web browser whether the request requested by the client was successful or not. Does it have a valid page or not? Okay. So a status code of 200 says that it was successful, and all of us know the very popular 401 page not found error. So what is 404 in that? It's nothing but the status code. Okay. So 404 is nothing but the status code, and it's a failure status code. Right. Okay. The second thing, the content type. So now say for example the status code was 200 and the server has found a valid HTML page for the request the client has requested. Now the server should have some way to tell to the client what type of content it is sending to the client, right? The content, as I've told you, it can be any static thing. So it can be a picture, it can be a static picture, it can be a jar file, it can be a static HTML file, it can be a text file, or one of the many other types the client actually can accept. Okay. So now, why is this so important, sending the content type to the client? Now say for example the content type was HTML. So the server sends back the content type as HTML. But the client, your web browser, should know what the content type is, what type of data is coming from the server, so that it can accordingly present that data or present that information to you, the end client. Okay. Now suppose the server had sent the content type as HTML. So what does the web browser do? The web browser, should make a note, is very intelligent to understand HTML. It's able to parse that HTML file and is able to render that HTML file to the end client in a very beautiful fashion, right? So as you know, an HTML file is nothing but it's a simple text with some HTML tags in it. It's got some HTML head tag and body tag and whatnot, right? But in the end, when the end user sees that HTML page, it's no more a simple file with some tags, but it's a very beautiful web page with some designs and some text boxes and whatnot, right? So when the server actually sends the client the content type, the web browser, the client, basically takes in that, and depending on the content type, it actually renders the information to the end user. So if the content type was a jar file, the browser would have actually opened up a dialog box allowing the user, the end user, to save that jar file in the desktop. Okay, so this is very important, the content type. And finally, the actual content that the server is sending back to the client. So these are the key elements that goes in as part of the request and the HTTP response. Okay, all right. So till now, what we've discussed was about only static pages. The client requests for a static page and the server sends back a static page. Now assume that the server, or basically the client, needs something which is not static in nature, which is dynamic in nature. Okay. So coming back to the example of Yahoo Mail, the first page you get, the Yahoo Mail homepage, is a static page. But when you type in your username and password and click on go get my mail, that is, the page you get after that is not a static page. It is a dynamic page, because if you type in the username as ABC, you get the emails for ABC. And if you type in the username as XYZ, you get the emails related to XYZ, right? So the second page is no more a static page. It's a dynamic page. So here a web server, as we discussed, can only handle static pages, and it can only serve static pages to the client, right? It doesn't have the ability to develop dynamic pages and send it across to the client. So how do you address this issue of developing a dynamic web page, a dynamic HTML page, and sending it back to the client? So this is where Servlets comes into the picture. You know that this web server application serves static HTML page. Now when the request comes for a dynamic page from the client, it knows that it cannot handle that request. It cannot serve that request. It says, I can only serve static HTML pages. So this helper application comes into play. It says, not a problem, I can handle dynamic request. Okay, and this helper application is nothing but servlets. So the mere existence of servlets came into the picture because client needs dynamic content and not static content always, right? So whenever you need a dynamic content from the server, you go for servlets. Okay, all right. So let's see how the flow goes from the client to the server. In the second slide, we saw as part of the request, the type of method is sent. And I told you that for now just assume that it's either get or post, right? So let's assume that the request type is of type get here. Okay, so the client sends a request to the web server and it's type of get. The web server will now take the help of the servlet to develop the page, because that is, it has to develop a dynamic page and it doesn't have the ability to develop a dynamic page. So it has to take help of the servlet ultimately to develop this dynamic page. This servlet now is nothing but a Java program. So this is some kind of a special Java program, you can say. The servlet is nothing but a special Java program which resides on the server. Okay. But this Java program doesn't have a main method. Okay. It has got some callback methods. So how does a web server communicate to the servlet? The answer to that is the web container, or it is also called servlet engine. Okay. So servlet engine is one which actually helps web server communicate with the servlet. Basically, servlet lives and dies within a web container. Okay. So a web container is responsible for invoking methods on a servlet. So a servlet basically has some callback methods which the web container knows, and that is responsible to call those methods on the servlet. So basically when a request comes in from the client, the web server will send that request to the web container or the servlet engine, and the servlet engine knows which servlet to call, which servlet can serve that request requested by the client, and it knows what methods to call on the servlet to get the information back from the servlet, right? Okay. So here, the previous slide is, we have just made it even more detailed. So let's see what happens again. We know this, the client sends a request to the web server and the web server sends a request to web container. Now it's the web container's responsibility to communicate with the servlet and allow the servlet to build the dynamic content and send the response back to the web container again, which will in turn send the response to the web server, which will ultimately go to the client. Okay. But one thing I want you to notice here is the request we have here, which is sent to the servlet, and the HTTP request here, which is sent to the web container from the web server, is different. So this request is not the same as this request. So what I mean by that, the request sent by the client, we know that it is a HTTP request because the server can only understand HTTP, right? So basically the client sends in a HTTP request and the web server again forwards that HTTP request to the web container. Okay. But as we have discussed, a servlet is nothing but a Java program. So how can a Java program understand what the HTTP servlet is? So it can only understand objects. Simple, right? So web container actually converts this HTTP request into a valid request object, and it sends across this request. It also creates a response object and it sends across the request and response objects to the servlet. Now again, the web container will spawn a thread for each request which comes into the servlet. Okay, and it calls the callback methods. As I told you, the servlet doesn't have a main method, but it has got some callback methods, and the web container basically knows what callback methods to call on this servlet. Alright, so you know that the callback method is doGet. Now say for example, if the request was of type get, the callback method which will be called on the servlet is nothing but doGet. Okay, right. So the container spawns a thread for the request that comes in and then calls the doGet method on the servlet. And within this doGet, you basically write your whole code, which will for the dynamic content, right? All your business logic goes either in doGet or it goes in doPost, which will be called if the type of method from the client was a post. Okay, so the doGet method is called, the servlet does all the processing in doGet, builds a response and sends back the response to the container. Now this response again is a Java object. It's a response object and it's not a HTTP response. So it sends back a Java object response to the web container. And this again now sends a HTTP response back to the client. It converts the response object into a HTTP response and sends it back to the client. So this is basically how a container is responsible to manage the whole life cycle of a servlet. So it is the container is responsible to invoke the servlet methods and send the communicate between the server and the servlet and send the response back to the client ultimately. Okay. All right. So what the role of a web container is in this whole web application? So we've already discussed most of it in the earlier slides. So as I told you, a container is nothing but it's a servlet engine in which the servlets and JSPs as well live and die. So it is responsible for everything that happens to a servlet, right? So everything that happens to a servlet is the container is responsible for that. Number one, communication support. What is this? This is a communication support between the web server or the client and the servlet. So all communication between the client and the servlet or the web server and the servlet is taken care by web container. So every request goes across web container. So the client doesn't directly talk to the servlet. The request goes via the web container. Right. Number two, lifecycle management. As I told you, the servlet has got some callback method. It's got some methods to initialize. It's got method to destroy the servlet. Right. So all these methods are invoked by the container, and it knows when to invoke which method. So basically the web container is responsible to create the instance of a servlet, invoke methods on the servlet, execute the servlet and ultimately even destroy the servlet. So that's the reason I told you that the servlets live and die within the container, right? Number three, multi-threading support. So as I told you, for every request that comes in for that particular servlet, the web container spawns a separate thread for every request that comes in for the servlet and processes that request. So web container provides multi-threading support for servlets. Number four, security. So since the client cannot directly talk to a servlet, it has to go through web container. So you can put in all kind of security code in that web container. So that only valid requests can go to the server, and any other request that is not valid will not be taken over to the servlet. So the servlet is going to serve only valid request, and that request is validated by the web container, right? And lastly, it also gives you JSP support, which we will definitely look in the later stages of this session. So servlet container, the web container, or servlet engine plays a very major role, right? So everything that happens to a servlet is due to the servlet container, the web container, right? Now, so we've discussed that a servlet comes into the picture when you need dynamic content, We've also discussed that the client doesn't directly talk to a servlet, it has to go via the web container. But now, how does the web container know which servlet can serve the request requested by the client? That's a question, right? There might be 5 or 6 servlets in my application which do different kind of jobs. Now, how will the web container know when a request comes in to the web server which servlet can help that request, right? Now, take the example, you clicked on yahoo.com and you entered your username and password and sent the request to the server. Now, how does the web container know which particular servlet in the web application can serve the request for that Yahoo email, right? So there is a servlet for Yahoo email. Say for example that servlet is Yahoo servlet, right? Now the container has to know that this Yahoo servlet can handle the request which was sent by the client for seeing his Yahoo mails. Now let's see how that happens. So basically there is a file called web.xml, and this is also called the deployment descriptor. So this is the main file for the web container. So this is like a master file for web container. Everything the web container needs is there in this file. So basically you have information about servlet in this file, the deployment descriptor or the web.xml. So as you can see here, it has got certain elements like the servlet mapping, etc. We'll discuss about what these elements are. So every servlet in the web application should have an entry into this file, the web.xml. So now say for example, my login servlet is a servlet which handles all the requests for login, Yahoo login. Okay, so I will have an entry for that login servlet in this web.xml file. So there is a servlet element within which I have servlet name and servlet class. So my servlet is login servlet. So I'll write the path to the servlet which I have, that is com.login, and I also give it some simple name, that is login serve. Okay, it's some readable name to that servlet which I am referring to. Okay, now you see that there is also a section called servlet mapping. Now what is this? So we have mapped actually the servlet class to some servlet name in this element. So that's fine. The servlet now can know, depending on this name, which servlet class to invoke and where that servlet is located. But how will the servlet know if the request was like yahoomail.com/login? How will it know that that request is for this servlet class? So that is derived from the servlet mapping element. So again, in the servlet mapping element you have two tags, the servlet name and the URL pattern. Servlet name again matches the servlet name you have in the servlet tag, and the URL pattern is nothing but the URL which the client has sent in as a request. So when the client sends in yahoomail.com/logon, it actually matches that URL here in the URL pattern tag. So it sees, oh, the client has selected this URL, so it matches this. It matches the URL present in this mapping. So it checks what's the corresponding servlet name for this URL pattern. It sees it's logon serve. Now it goes to the servlet element, and so apart from these servlets and servlet mapping elements, there might be a number of servlet and servlet mapping elements similarly for different servlets, right? So it checks all the servlet elements and it matches this servlet name with the servlet name in the servlet element. So it says, okay, I found a match. Now it goes and checks what the servlet class is for that particular servlet name, and it goes to this path, that's com.login, and ultimately it picks up that servlet, invokes the methods on that servlet, processes the request, and sends the response back to the client. So this is how basically communication takes place. So this is how a web container can match a request sent by a client, the URL, to a valid servlet, which is actually serving the request sent by the client. Okay. So these are the three different servlet names. We have the client known URL name, that is the URL pattern. The deployer known secret internal name, that is nothing but the servlet name, and the actual file name, which is nothing but the servlet class. So why do you have these three different names? You can assume, you can think one reason would be for simplicity. You don't want your client to actually type in the whole path to your servlet, right? You don't want your client to type in like com.login or whatever big path you have for your servlet. You want the client to give a simple name, something very simple, right? Instead of you giving a yahoo.com URL to your client, say for example you gave com.yahoo.login servlet, that would be very difficult for the client to understand, right? So you want simplicity there. So that one of the reason. Second reason, you can say security. You don't want everyone in the world to know the actual path to your servlet, right? So once someone knows the path to your servlet, it's vulnerable to security, right? So you can have anyone breach in your security. There is a possibility, right? So you don't want to take a chance with your security aspect. So that is one of the reasons. Okay. So basically this is how a web container manages to map the servlets with the incoming request and actually complete the request sent in by the client.